Projectile motion. Projectile motion. Motion is change of position. With time. And projectile is a body projected or thrown near earth surface. So, the definition of projectile motion. Definition of projectile motion. Motion of a body projected near earth surface is called projectile motion. Projectile motion. There are many ways in which we can project a body near earth surface. As for example, if this is the earth surface, if this one is our earth surface, this one is a projectile, we can project at an angle theta at some speed u, and body goes like this. Or there is earth surface, there is a building, we project body, and so body goes like this. Or there is a tower, of some height, and we have to project a ball horizontally like this. Or we can project from the same tower at an angle, so body comes like this. Or from the same tower, we can project like body this, and body goes like this. In another sense, Suppose there is an aeroplane. There is an aeroplane and we can project a ball at some speed v, so that body comes like this. Or we can project a body on an inclined plane like this. Projection on inclined plane. Or we can throw or project a body like this. Or from a moving trolley. We can project a projectile like this, or like this, or like this. So there are many ways we can project a body near Earth's surface. There are mainly three ways in which projection is done. First one is oblique projection, or projection from Earth's surface. Second one is projection from a height. Third one is projection from Earth's surface on inclined plane. Now we have to go through mathematics of all these three types of projection. First of all, projection from Earth's surface. This is mainly known as oblique projection or angular projection. From Earth's surface we have to project body at some initial speed u, at some initial angle theta. This angle is known as angle of projection. This speed is known as initial speed of projection, and this one is our Earth's surface, and gravity acceleration is g. We can break the components of a speed along the surface and perpendicular to the surface. As suppose this one is our Earth's surface, so a speed u have two components, u cos theta, another one is u sin theta, and acceleration due to gravity is g. As we seen, in this direction acceleration is 0 and in this direction acceleration is not 0. So in horizontal direction motion is uniform, and in vertical direction motion is non-uniform. So in oblique projectile motion, body moves such that horizontal motion is always uniform and vertical motion is always non-uniform. So in oblique projectile motion, projectile have u cos theta along x-axis and initial speed u sin theta along y-axis, and acceleration due to gravity opposing u sin theta. After time t we can calculate x equals to u cos theta into t, and after time t we can calculate y of the body, u sin theta into t minus half gt square, as motion is non-uniform. So there are mainly two equations regarding oblique projection. Two equations. In oblique projectile motion, path of the body is a curve 1, x equals to u cos theta t and y equals to u sin theta t minus half g t square. Putting t from 1 in second, we get y equals to u sin theta and t is replaced by x over u cos theta minus half g x over u cos theta का whole square. So u gets cancelled. So we get an equation. We get equation y equals to tan theta into x minus g 2u square cos square theta into x square. This one is a equation of an equation of parabola. So in oblique projectile motion, path of projectile is parabolic in nature. Path of the projectile is known as trajectory. Path of the projectile is known as trajectory. So trajectory is parabolic in nature. Now suppose in oblique projectile motion we have to calculate time of time of ascent Ta. Ascent is the phenomenon in which height of the body going to increase. This is the ascending stage. Time taken is Ta. In this part, initial speed is u sin theta, retardation is g, initial speed u sin theta, retardation g, and at the final stage of ascending, speed becomes 0 because of retardation. So v equals to u plus at can be applied along y-axis. V final is 0, initial speed is u sin theta, acceleration is minus g, and time is Ta. So Ta comes out to be u sin theta over g. Ta comes out to be u sin theta over g. As parabola is a symmetric, as parabola is a symmetric, parabola is a symmetric in nature. So time of ascent equals to time of descent, that equals to u sin theta over g. And what is about time of flight? Time of flight is nothing but Ta plus Td, ascending plus descending. So time of flight comes out to be 2u sin theta over g, here 2 uy over g. This is the time of flight. This is the time of flight. Suppose we have to calculate greatest height. Suppose we have to calculate greatest height. In achieving the greatest height, initial speed is u sin theta, final speed is 0, and this is the greatest height h. Retardation is g, or time taken is time of ascent, that is u sin theta over g. We have a formula for the displacement u plus v by 2 into t. We can apply here. S is h, u is u sin theta, v is 0 over 2, and time is u sin theta over g. So greatest height comes out to be u square sin square theta over 2g, or uy square over 2g, This is the formula for greatest height. In another example, suppose we have to calculate range. What is range? Range is the maximum maximum horizontal displacement. Maximum horizontal displacement. We have seen in projectile maximum horizontal distance is this length. So this length is known as r, range. How we can calculate r? As taking motion along x-axis, x equals to ux into t. So x equals to ux is always u cos theta and time is time of flight. X equals to u cos theta, time of flight is 2u sin theta over z. So x comes out to be 2 u cos theta u sin theta over z, or it is u square 2 sin theta cos theta over z. So we can arrange these equations for range. Range comes out to be 2 ux uy over z, or u square sin 2 theta over z. This is the general formula for finding range. Finding condition for maximum range. Finding condition for maximum range. R equals to u square sin 2 theta over z. R will be maximum when sin 2 theta is maximum, and sin 2 theta is maximum when 2 theta is 90, theta is 45 degrees. So maximum range achieved when theta is 45 degree, angle of projection is 45 degree. Find condition for achieving same horizontal displacement or same range. R1 equals to u square over z sin 2 theta 1, and R2 is u square over z sin theta 2. If R1 equals to R2, sin 2 theta 1 equals to sin 2 theta 2. Therefore, sin 2 theta 1 minus sin 2 theta 2 equals to sin c minus sin d. Sin c minus sin d. 2 cos c plus d by 2 into sin c minus d by 2. So 2 cos c plus d by 2 into sin c minus d by 2 2 cos theta 1 plus theta 2 sin theta 1 minus theta 2 equals to 0. This equation is true when sin theta 1 minus theta 2 equals to 0 or cos theta 1 plus theta 2 equals to 0. If sin theta is 0, theta is also 0. It implies theta 1 equals to theta 2. This one is a true statement. Cos theta is 0 when theta is 90 degrees. So theta 1 plus theta 2 is 90. So this is the condition. If for a first projectile angle is alpha and for the second projectile angle is beta, then alpha plus beta must be 90 degree. Means angles are complementary. For getting same range, angles of projectiles must be complementary. When they are projected from same position with the same initial speed. With same initial speed.